Hello again. In this lecture, we will discuss about prefabricated steel sections as opposed to the more general custom sections. Just to remind you, the general custom sections would be simple sections like squares, rectangles, triangular sections, circular sections, and so forth. But with regard to prefabricated steel sections, let's start with the first type of section, equal leg angles, which is the same section that we discussed before when we analyzed and designed trusses. This is a steel section that has the shape of letter L, and when the two legs are equal, it means that the dimensions denoted as B in this picture are the same. So both of those components of the sections called legs have the same dimension B. The other property is the thickness of the wall of the section, which is T. Therefore, we designate a section like this with a capital letter L indicating an angle, and then its dimensions B times T. So for example, angle 150 by 150 by 13 millimeters. Now, we're going to talk about a few other sections, and one is the wide flange sections. Due to the shape of these sections, they're also known as I sections because they resemble capital letter I. Like so. So they're composed of a vertical web and two horizontal flanges, like so. Hatching means this is a cross section of an element and not an elevation. The depth of the section is normally denoted by D. The width of the flanges, which are typically equal in width, is B. The thickness of the web is W, and the thickness of the flanges is T. The designation for this type of section starts with capital letter W, and that indicates a wide flange section. So letter W indicates that. And then two numbers. The first one is the approximate depth, not the exact depth, the approximate depth, as well as the mass per unit length, which is a parameter that is very useful when we select the most efficient, economically efficient section, because we're going to look at the lightest one. For example, one such beam would be W610 by 125. So 610 approximate depth in millimeters, 125 kilograms per meter would be its weight. It's mass per unit length, actually, not weight. Another type of section, roll section, is a channel. It looks like so. It's kind of like a half of a wide flange section, really. And the depth of the section is D, and the width of the flange is B, and also the thickness of the flange is T, and the thickness of the web is W. Again, the designation will start with letter C, capital C, which indicates a channel, and then two numbers which have the same meaning as for wide flange section. So the first one represents the approximate depth of the section, and the second one is the mass in kilograms per unit length, per meter of the section. So same as for the wide flange sections. So for example, a typical channel section would be called C250 by 30. And since channels in cross section, they look like letter C, they're also known as C sections. Now, the last type of section that I would like to mention are hollow structural sections, and often they're called, of course, HSS members. Now, these sections are hollow. They can be square, rectangular, or circular. So in the case of a rectangular section, such a section would look like this one, being characterized by its external dimensions. So these would be the depth D, and the width of the section. Again, these are external dimensions. The width B, and the wall thickness of the section denoted by T. Now, the designation of such a section would start with the capital letters HSS, indicating that this is a hollow structural section, followed by the exact external depth and the exact external width and the wall thickness. So, for example, such a section could be HSS 127 by 76 by 6.4 millimeters. Now, as you can see in all these diagrams, I also showed the centroidal axis, X and Y. Their location is very important, and please do remember that these axes rotate with the section. They are glued to the section. So if the section rotates by, say, 90 degrees, then the axes will also rotate 90 degrees with the section. So the x-axis will become vertical and the y-axis will become horizontal. Now let's look at a couple of typical sections. Again, say a wide flange section W610 by 125, and see how we can extract the important parameters from tables where the properties are given. So one important parameter is the actual depth, and you can see here that for a W610 by 125, the actual depth is not 610, that is the approximate depth. The actual depth is 612 millimeters. And secondly, the mass, the unit mass of this section is 125 kilograms per meter, which is given by the second number in the designation. What we need for design or even for analysis are the section moduli for the x and y axes, and they can be obtained from the corresponding columns. Now for C channels, for example, a channel 250 by 30, the procedure is similar. The information in the table is slightly different because you are given the mass by the designation, by the second number, 30 kilograms per meter, and the approximate depth is of course 250. The exact depth is not given in this table, but it would be typically given in another table. So this column is missing here. Now, the weight per meter long is also given as a dead load, as you can see here, 0.291 kilonewtons per meter. So that should be equivalent to the mass of 30 kilograms per meter. And the section moduli are given in their respective columns, Sx and Sy. Now finally, for hollow structural sections, this is another table specific to them. So for example, if we're looking up HSS 125 by 76 by 6.4 millimeters, then we can easily determine its unit mass per meter from this column. So that would be 18.2 kilograms per meter for this section. And of course, the section moduli Sx and Sy can be then obtained for their corresponding columns. So again, please note the type of expressing these sections, their designation, their numbers, they don't always have the same meaning, but you should always be able to get the necessary parameters from the corresponding tables, from the appropriate tables for those sections. So I would like to thank you very much for watching this video, and in the next couple of videos we will continue by doing some actual examples.